is being asked here in question 19 or talked about. Okay, so corresponding sides should be what when we do a reflection? Yeah. What they're saying here, so if this is my image, okay, and this is my pre-image, okay, when we do a rigid motion, which a reflection is a rigid motion, we've talked about the size and shape is not changed. Therefore, we say distance is preserved, so distance is saved, meaning that this 16 is going to match up to that 4y, right? So I get 16 is equal to 4y. We should be able to solve that. What is 2z minus 1 going to match up to? Yep. Okay. And then 20 is going to match up to, 20 is equal to 5x. So those are all things that, once we set them up, are things that you could solve. Y would be 4 here. Z would be, what, 25 halves. And then here we get x to be 4. It says type integers or decimal, so this one needs to be changed to a decimal. Turns into 12 and a half, right? Okay. So that's, put that in there to see if we remember through the discussion that we had that distances are saved when you do reflections. Okay. We can do the same type of thing when we do rotations. We can do the same type of thing when we do translations. Those similar types of questions can appear because those are rigid motions, and distances are always saved in rigid motions, meaning that your image and your pre-image are always congruent shapes. Okay, so you can use corresponding parts of congruent shapes are congruent to set up those equations. Any others? 21. Okay, for the given points, segment A prime B prime is a translation of segment AB. Write a rule to describe each translation. Okay. Just to organize things easier, I'm going to actually just graph this real quick for us. So we've got A at negative 1, 1, B at 6, 1, A prime is at 2, 3, and B prime is at 9, 3. Okay, so they want us to come up with a rule for this translation. So this is going off of what we talked about on Monday and Wednesday a little bit. Okay, so those are your two shapes, right? I said A prime, B prime. A prime, B prime is a translation of AB, okay? Meaning that A prime, B prime, let me get back to whichever one I had open here. A prime, B prime, that one there is your image, okay? And this one here is your pre-image. Okay, if we don't have that structure set up, your translation is going to be wrong. Okay, because A needs to go to A prime and not vice versa. Does that kind of make sense? Okay, if I'm at A, I'm going to move positive in the x direction to get to A prime. If I'm at A prime, I would move negative in the x direction to get to A. Does that make sense? So that's the idea of why we've got to make sure we know which one's the pre-image and which one's the image. So now it's a matter of just saying what is our rule? What is the distance here that A needs to travel in the x direction to get to A prime? What is that distance right there? Okay, so 3 units there. And what is that distance there? 2. Is that the same for B? Does it need to go 3 and then up 2 to get to B prime? Okay, so there's my rule. Now we got to talk about the ways that they ask us to write this. Okay, yeah, so they're asking us as using this notation, so they're saying x, y becomes, now we're going to write x plus 3, and then y plus 2. And that will be the rule then that we're going to use to develop that translation. The other way we could do this is we could write something like that if they were to ask that notation. If they're used at capital T. I think some questions earlier in the 9.1, the first 9.1 assignment asked you every once in a while to write it this way. But they had the T already there, and then they just had like boxes down here that you had to type in, right? So you might see and the reason I'm giving you multiple notations like this is because I don't know how they're going to write that on the enforced exam. Okay. Now here's another way, the guys, that we can figure this out. How can I get this 3 and how can I get this 2 without looking at the picture? A needs to go to A prime, right? Okay. Is the distance between those x values 3? Yeah. And B, all right, let's go. So that was the x values. Now look at the y values. Is the difference between those y values 2? Okay. Now, the only issue here is I find those distances to be 3 and to be 2. Now I just got to make sure A is going to A prime, so the 3 needs to be positive. And so does the 2 in this case, okay? If I was going from A prime to A, then they'd be negative, even though the distance is still positive 3. Does that make sense? Okay. But that's a way of doing it without having to draw a picture, without having to go that route. Now, obviously this is more efficient, but isn't the picture a lot safer to do? Yeah. Okay, and it's not that hard to draw that picture. Others on here. Okay. So in doing 8, so we got the 0.34. Let's see here. Wish there was a better way I could zoom in on this. We can do it this way. Whoa. So we're using this rule to determine the location of A prime. Well, now it's a little bit different notation than what we used yesterday. Yesterday, we actually put the ordered pair here, right? They're putting the capital letter for A, but in that capital letter, it's still an A comma B. Does that make sense, everybody? In reflecting across the line y equals x, we said yesterday that rule is that they flip-flop, okay? The x becomes y and the y becomes x. So now, if I'm looking at this point right now, and I know you can't really see it real well, it says 3, 4, okay, is that point. So what's it going to become when I flip-flop it over the line y equals x? 4, 3, okay, and it's going to go right there. So there is A prime, okay. Now the second part of this question says we are going to, we're going to reflect over the line y equals negative x. But now we're going to use A prime as our pre-image. And the image that we're going to get is going to be called A double prime. So now we're taking this blue point and we're going to reflect it over this line y equals negative x. Well, yesterday we said if that was A comma B, then when reflecting over the line y equals negative x, the image, if you remember, is opposite of B comma opposite of A. Does that make sense? So here is A prime. I'm going to flip-flop them, so it gives me 3, 4, right? And then I'm going to make them both negative. Okay, so negative 3, 1, 2, 3, negative 4 should put me right there. So there's A double prime, negative 3, negative 4. Okay? My argument is when you're doing this by hand, I mean, does that make sense? If I fold it on that line, does this blue point fall on that red point? Okay, so you know you've probably done things correctly so far. The third part, part C, says we're going to reflect across the line y equals x of A double prime, and that's going to yield A triple prime. Okay. Well, yesterday, if this was A comma B, okay, this rule, again, we've already used it once, right? We used it up there. It's A comma B, it becomes B comma A. So now all I gotta do is flip-flop these, right? So -4, -3 is what we're looking at. Would be that point right there. So this is all getting kind of muddled, but that would be A triple prime, and it's going to be -4, -3. The last one then, the last reflection we have to do is across the line y equals -x again, but now we're using A triple prime to do that, and that's going to yield A. Now, they write it that way, quadruple prime, okay? A lot of times when you go beyond 3, they'll put a 4 up there, okay? That's notation that maybe if you were to see this question on the end of course exam, that it uses a 4 instead of a 4 tick marks. Does that make sense? Or 4 apostrophes, whatever you want to call those. But that is the same thing as that, okay? And we talked right here what happens when we have that. If that's an A comma B, then to get this point here, you flip-flop them and negate both of them. So let's flip-flop these. So it's going to be -3, -4, right? And to negate those, what's -3 negated? 3. What's -4 negated? 4. So A quadruple prime is right there at 3, 4. And that should give you the relationship that they're asking for right here. How are A and A quadruple prime related? They're the exact same point. Okay. So those 4 transformations, those 4 reflections, take a point and map it to itself. Okay. And that's something that entire branches of mathematics are kind of devoted to, is understanding what kind of things do that. Okay, what kind of rules can we use that will take a point or some object, maybe sometimes a number, and take it away from itself, but then eventually bring it back to itself. Okay, and we do that a lot with things. If you think about how we do it with functions, x squared and square root of x. Talked about it a little bit yesterday. Okay, x squared takes a number like 3, takes it away from itself and makes it 9, right? But if I run it through the square root, it takes that 9 and brings it back to 3. Okay, we're interested in those types of relationships because they're very useful to us. This is a useful concept here. Okay, for a lot of higher level mathematics. That's a good question to ask about that. One more that I want to talk about. I think it was 19 maybe. Nope. 20. Yep. And we kind of got into this yesterday. Was everybody 0, 0? Okay, we can talk about that too, if we can find it. This one's easier. Okay, and this is referred to as analytical geometry. And we've talked a little bit about this before, but right now with analytical geometry, one of the most convenient points for us is 0, 0. That's the nicest thing. We're going to reflect this across the line x equals a. Now, here's the thing. We don't know what a is, right? A is just some arbitrary value, okay? Now, it could be negative or it could be positive. Which one would be kind of the best for us to use? Positive, okay? But the argument is that we don't know what it is. It could be negative. But I'm going to put in that line. That's L1, which we're saying x is equal to a. Okay. Says, and we're going to do that reflection, and then we're going to cross it or reflect it across our line here in a little bit. So let's first do this one. Okay, let's do this reflection. If we were to fold in that dotted line, you guys would see that this point falls over here somewhere, right? But we got to figure out what its location is. What would its y value be? It's got to be 0, doesn't it? It's on the it's on the x-axis. It's that point reflected across this line. So if that point's on the x-axis, its reflection better be as well. Okay, it's horizontal reflection. Now, we got to figure out what this distance here is. What is that distance? And it all comes from that line right there. What is the x value that line is passing through? It's a, right? So isn't this distance here a? For instance, if we had the line x equals 3, this would be a 3 right here in the coordinate plane, and then you could argue that this would be 3, right? But if it was 4, that'd be 4. If it was 5, that'd be 5, correct? If it was 3, what would that distance be? That distance would be 3. I heard somebody say 6. 6 would be the distance from 0, 0 to that point, right? If this is x equals 3, if this line is x equals 3, this red dotted line, we know that distance there would be 3, right? And then when we reflect, what is that distance there? It's also got to be 3, right? So now the question is, if that's the case, if we're letting this be a specific value 3, what would that distance be? It'd be 6, right? Now I'm going to write it this way. 2 times 3. Okay, that's still 6. You agree with that? But here's the purpose of writing it that way. What if this x equals 3 was like 5? What would this distance be? 5. What would this distance be? 5. And what would I write this as? Yeah. 10 or 5 times 2 or 2 times 5, right? Does that make sense? Well, what happens then, I see a pattern here. If that's A, what is this? A. What is this? A. And this would be 2 times A. So that is the ordered pair for that point when I just have this arbitrary line A, x equals A. Does that make sense? Yeah, because now the next part says, and then cross the line, or then reflect across the line, y equals x. So now I'm going to take this point right there, and I'm going to reflect across that line y equals x. Is that all right, everybody? So I'm going to erase this to clean things up a little bit. At least erase some of it. Okay, so now we have this point 2a comma 0. And we're going to reflect that now across this line here, y equals x. Well, what was the rule for reflecting something across the line y equals x? If it was a comma b, it became what? B comma a. So right now, and ultimately, we can use any letters we want to. It might make more sense to use like because we're already using a for something, it might make sort of sense to m comma n. Then it becomes n comma m, all right? This is your m, that's your n. Flip-flop them, so it gives me 0 comma 2a. And that's where that point would be. Does that kind of make sense to everybody? Okay. So this can be done regardless of what your initial point was. Okay. It's really nice to use 0, 0 because that distance is easily created by 2a. Okay. But if that distance is now, and let's say I start at 1, 0, well, now that distance there that I reflect across A is not strictly 2A because it's got that additional value of 1 kind of needing to be incorporated, right? Okay. Was there another one then on here that was similar to that? Let me zoom through here real quick. This one here? Yeah. So you keep doing those. We call them compositions of reflection. So we have like a reflection of y equals x, and then we compose that with y equals negative x, and then we compose that again with r of y equals x, and keep doing that. But all that means is that you do this one, then followed by that one, then followed by that one, and that is exactly what's happened there in 19. I guess my question was there one on here? And if not, I won't spend time because I don't know that you're gonna have to do this. Was there one where it said something similar to that, where maybe you start at let's just still say, and we can at least do this one, it's not too hard. If I start with that line at x equals a, but now instead of taking 0, 0, let's take a point, because 0, 0, because 0, 0 is a good starting point, it's easy to find that distance is a, right? Okay. Well, what if my starting point, what if that's the point that I want to reflect? Okay. Let's call that point, now let's go m comma n again. Okay, m comma n. And it's just, m and n are just arbitrary numbers. Okay, it looks like they're 2 and 2 here, right? Or maybe if I move it right a little bit, maybe it looks like it's 3 comma 2. And I want to reflect that over this line x equals a. Give himself a little bit of room. What would you do to figure out that distance right there? Say again? A minus, right, it's a minus whatever that x value is. So if that is legitimately 3, 2, then yeah, it'd be a minus 3. Let's just call it m. So we see that this, to find distance on the x-axis, anywhere on the x-axis, or in between any two numbers on a number line, you just subtract them, right? And we know in this case, a is to the right, so I'm going to put that one first because it's going to be the larger value. And in the whole grand scheme of things, it really doesn't matter. But this distance here would be a minus m. For instance, let's use some arbitrary values and see if this makes sense. What if this was x equals 1, 2, 3, 4, 5, 6, 7, and this was the point 3 comma 2? Okay. Would you see, so that point, that x value is 3, that x value is 7. Can you see that you're taking 7 minus 3 to get that distance? Which is a was 7, 3 was m, right? So you're doing a minus m. Is that okay with everybody? Okay. I think it's a really good idea a lot of times when you're doing these arbitrary values to every once in a while kind of stop and think, okay, what if I put real numbers in there? Okay. Is my relationship with the real numbers that I've developed here arbitrarily, is that relationship going to hold true when I choose real numbers? Okay. What would this distance here be when I do the reflection? It's still a minus m, right? It's got to be the same. That's what we talked about this. So this question is getting at the idea, understanding that that distance is preserved when you reflect. So my point here, let's call this P over here, and we'll call this P prime. My point P prime is going to have an ordered pair. Now, what is the y value of this P prime? It's got to be n. It's horizontal with this blue point, right? Okay. But now we got to figure out, how do we go about finding what this x value is? And the idea is, how can you go from, x values are all defined off of the origin. What is that distance right there? Okay. Well, isn't that distance comprised of that distance plus then that one? Does that make sense? What is this distance right here? A. And what was this distance right here? A minus m. What can I do with those to go from here to here? Add them together. So a plus a minus m is 2a minus m. 2a minus m, and then comma n. Okay? And that's going to be the ordered pair. And that guys, that could be a rule. Let's say we have a rule that we're going a reflect x equals, across the line x equals a of some point m comma n. That then becomes 2 A, which that A right there is related to the A right here. They're the same thing. And then minus M, comma, N. And if you want to remember that, just like I gave you 4 yesterday that you can remember, that is perfectly fine. There's nothing wrong with it. It's kind of messy, all right? So it might be something hard to remember, but it is true and it will always be true. And you can then say, okay, what if I start choosing arbitrary values? Okay, let's see if this works. Let's see if this formula does indeed give me what I think I should get. Okay, so let's just make things easy. We'll go to GeoGebra here and put in. Okay, so we had, let's write the rule here. We had R x equals A of what we call Mn was equal to 2A minus M, comma N, right? Let's just choose an arbitrary point, okay? Or not arbitrary. Let's actually make a specific point. Let's go, I don't know, 6, comma 1, okay? What line you want to reflect it over? Give me another number. If I go over 6, it would be the same. The line would go through A, and it's really not going to be really interesting. So let's do 9. It's fine. So now I'm going to reflect that point. So this point right here, guys, this is M, and that's N, right? Okay, and we know it's 6, comma 1. Okay, if I reflect across x equals 9, just using what we know about the picture, that distance would be how far? 3, right? So that needs to be reflected over here as 3, and this point would go to 12, comma 1, right? Does this rule produce the same thing? If M is 6, N is 1, R for reflection, x equals x, the A value is now 9. Does that make sense, everybody? So what is 2 times A? Be 18, minus M, which would be 6, comma then N, which is 1. Is that ordered pair right there the same as that one? 12, comma 1, right? Now the idea is that you would want to do that more than once to make sure that it's just not happenstance, just coincidence that occurred, and we do get the same answer. Sometimes that does happen when you create a formula like this. It might work for a handful of them, but it doesn't work in general for all of them. We would actually want to go through a little bit better of a proof than what we've done. Look for counterexamples, but that is going to be that's going to check out every single time we do it. Okay, and I guess I said we didn't do it. We really did do a proof when we came up with a 2A minus M, comma N, because we didn't use any numbers, right? We used arbitrary values, so it is ultimately an algebraic proof. We can do the same thing with a vertical reflection. So reflecting over a line like y equals A, something like that. But I'm not going to do this with you. But let's say that we are interested in reflecting across like y equals A there. Well, the only thing that happens, so if this point is A, let's call it Mn again. The only thing that really changes is now when I reflect it, the ordered pair is still going to have an x value of M, right? But what is this value here? What's this y value going to be? It's going to be 2A minus that N value. Does that kind of make sense? Okay. It's the same formula. It's just that now that part of the formula is in the y location instead of the x location. Okay. I don't know that you need to memorize those. I think if you ever get across one of those questions, it's probably logistically makes a little bit more sense to just do the specific problem they give you instead of trying to create the formulas. That's my opinion. Okay.